Okay, we're going to talk about section 1.8, which will be the absolute value equations and inequalities. So I want to remind you about absolute value. First of all, whenever we think about absolute value, it's the distance from zero. For example, if I said, what's the absolute value of 3? How far is 3 from 0? 3 units. And if I said, what's the absolute value of negative 3? It's the same answer. Whether it's negative or positive, it's 3 units from 0. So absolute value is just a distance, and it's neither positive or negative, but just, or you could say it's the positive. Think of it as dropping the signs. It's just the distance from 0. So what we're doing today, we're solving equations for x like this. If I said the absolute value of what number equals 3, that's why there would be two answers. The absolute value of 3 equals 3, and the absolute value of negative 3 also equals 3. So there's two answers to that. So it's like you just drop the absolute value sign and then say the positive and as well as the negative. Two answers. So if we were doing an equation like you see on example 1, if you're following along in your textbook, that asks you to solve this equation, the absolute value of 5 minus 3x equals 12. So we've got a more convoluted expression in this absolute value sign. So I can't just look at it and tell you the answer as quick as I could on the last one, but it's the same process. There's two answers for this. Whatever makes whatever this is in the absolute value sign equal positive 12, and whatever would make that value equal negative 12. Two answers again. So we set what's in the absolute value sign equal to 12, asking this problem is asking what can I plug in for x, times it by negative 3, and add 5 to it, so that would equal 12, because the absolute value of 12 would be 12. That would solve it. And then we'll do it again for the negative. We'll do 5 minus 3x equals negative 12. So that's the reasoning behind it. There's two answers because the absolute value of 12 will equal 12, and the absolute value of negative 12 will also equal 12. But procedure-wise, you could say it works out to where you drop the absolute value signs and you write it equal to 12, and you write it again equal to negative 12. And then you solve these two equations. So I'll throw the 5 across the line and solve this little mini equation and get the answer of negative 7/3. The negative can be on the top or the bottom or the outside, but it's a negative 7/3. That's one answer that solves this. And then the other answer, I throw the 5 across the line, and I get negative 17. Divide both sides by negative 3. A negative over negative is positive 17/3. So those are our two answers for example 1. Okay, so you should try this. You know, I like for you to do some practice problems. You can pause the video as if you were in class and practice this. So that you try for this example, I would have you do is the absolute value of 9 minus 4x equal to 7. So pause the video and get your two solutions for that. I'm going to keep on talking though and assume you did that and then you came back in. So there's two answers to this. Whatever makes this quantity 9 minus 4x equals 7, and whatever makes 9 minus 4x equal negative 7. So I solve those two mini equations. I throw the positive 9 across the line, giving me negative 4x equals negative 2. Then divide negative 4 to each side, and that fraction will reduce to a positive 1/2. So one of your answers should have been positive 1/2. Then do it again here. Bring the 9 across the line. Negative 4x equals negative 16. Divide both sides by negative 4. The other solution is positive 4. So two solutions, 1/2, comma 4. Two numbers that solves that equation. You should plug it in and check it to see that it's so. All right, the next part of example 1 has an absolute value equal to an absolute value. So absolute value of 4x minus 3 equal to an absolute value of x plus 6. So this is a little different reasoning for how we're going to solve this, but if you think about it, all these make sense, I guess, when you break it apart. But we're just trying to make these two sides equivalent. What would solve this to make these two sides equivalent? There's also two answers to this, like we just saw in the last example. It's whatever would make these equivalent. we don't actually have a number to know what number we're trying to achieve here, but what can we plug in for x that makes these two come out to be the same number so that their absolute values are the same? And then the other scenario would be what would make them opposites of one another. Say this side was a 7 and this side was a -7, just for an example, because I don't know what the number is going to be here. But if this side were 7, absolute value 7 would be the same thing as the absolute value of -7. Their absolute values would just be a 7. So whatever makes them opposite plus whatever would make them equivalent. So two scenarios again. So set these two things equal, these two quantities equal to one another to find out what we could plug in for x to ask the question what makes this quantity the same as that quantity. And then we can solve that for x. That's 3x. And then -3 thrown across is +3. Divide both sides by 3. So if x equals 3, these two sides are equivalent. I wonder what number that it would be, because we really don't know that part from what we've done here. We just know this would work. But let's just, for the fun of it, let's just see what happens when I plug in 3 here. I get 4 times 3, which is 12. 12 minus 3 is 9. I would get a 9 on this side. And over here, if I plug x as 3 in, 3 plus 6, oh, that side's also a 9. So it did do what we set out to do. We asked it what value for x makes this quantity the same as that quantity. We did our little equation solving. We got an answer of 3. And then you can check it. The number seems to be 9, but nothing special about that, but notice it works. This side is 9 and that side is 9, and then their absolute values would thus be the same. The absolute value of 9 is 9. So that's one answer, x is 3. Then we repeat this and ask, well, what would make the two sides opposite? I don't know if it's going to be 9s again, like a 9 and a -9, but maybe it might be a different number. But what would make this quantity the opposite of this quantity? Same number, but different sign. Now, how are we going to do that? You can do either side with a negative sign. That's up to you. I think I'll just leave this side alone and make this side the negative side. Do the opposite of this side. So -1 of x plus 6. And that would suit for what I'm saying here. These two sides are opposite signs, but equal numbers. So I'm distributing a negative sign just to one side of this equation, right? You don't want to do both sides, or that would be back to being just the same, equivalent. So just one side of negative. Then gather your x's, gather your constants, divide by what's with your variable, and it's a fraction. That's okay, it's still a number, right? So -3/5 is the number that makes the two sides opposite. So we could check that out just like we did the last one, plug it back in for the x's, and see that it's so. So let me show you that. Not as friendly or as easy for me to check, but if I plug in -3/5 minus 3, and for both of these sides, I'll probably just use my calculator for this, right? I might plug it in on my calculator and get it as decimals even to check, but let's see, -3/5 plus 6. If I were doing this by hand, just for the fun of it, while we get like denominators of 6, of 5, and this would become a 1 times by 5 there, so times 5 to the top, 30. That would be 27/5. That's the number I get for this side. So this side should be the same. Let me just do this little fraction work quickly. Of course, like I said, you'll feel free to use your calculator. But if I got a like denominator of 5, that would be 15/5. Look, -12 minus 15, that's -27/5. So the two sides come out to have that same number. Like I said, nothing magical about what number it is, but they do have the same number, but opposite signs. So it works, and that should be the only two solutions. We need to look any further. What makes them the same? What makes the two sides opposite? So we found the two solutions. So once again, and then we'll have you do a U-try. To solve an absolute equals to an absolute, you drop the absolute value signs and just set them equal to one another to see what would make the two sides the same number. And then you do the other equation making one side with a negative, just timesing one side through by a negative to address what would make them opposite signs, but their absolutes would be the same. Alright, so I have a U try. As always, pause the video to do your U try, and then come back in. But I will keep rolling. The U try is absolute value of 3x plus 2 equal to the absolute value of x minus 5. So the process is to set these two sides equal to one another. So 3x plus 2 equals x minus 5. And then to also do it with one side as a negative. So I'm going to leave the left side alone and times